Okay, here we go. Let's put all of the formulas you learned to use. This is just an exceptionally good question. It says you got a ball. It's dropping from a height of 100 meters. So there's 100 meters. Here's your ball right here, and it's going to drop. Now think about it. Your ball is going to drop. It's going to come back up, and it's going to continue along this nice little path on and on and on and on and on. And guess what? It's going to eventually just start to roll here. Okay, so obviously if you think about this, it says right here, it only goes up to 75% of its previous height, which if you think about it, 75% is 0.75. So guess what? This is a convergent series. You betcha. Why? Because eventually there's going to be no bounce and it's going to be zero. Yay! And think about it. If that's your ratio R, it is in fact between -1 and 1 because it's 0.75. Holy smokes, that's awesome. Okay? Now, you've seen a question similar to this already in a previous podcast in the last section. But I want to do it again because look what happens. It says after how many bounces is it going to take for it to reach a height of 13.3 meters? Okay, so somewhere along here, it's going to eventually become a height of about 13.3 meters. This is what we're going to have to figure out. So if you think about that then, we are actually trying to find Tn. That's what we're trying to find. We're trying to find how many bounces. That's how many bounces. We're trying to find n. This 13.3 is Tn. Find me n. How many bounces does it take? Well, before we do that, you have to remember a couple things. Remember, this is not T1. After the bounce, after the first bounce, there's the first bounce, that now becomes T1. So if you think about it, you've got 100 meters, you're going to bounce once, so multiply by 0.75. Your T1 is actually 75. That's the important way of doing these. You have to remember that's what your T1's going to become. All right then. Here we go. Use the formula that you've always used. I know it's infinite, but you can't use that formula yet because you're not finding a sum, you're finding a term. Tn equals to T1 R to the n minus 1. Do you remember that formula? Whew, blast from the past, I tell you. So let's find this Tn. The Tn, if you think about it, is 13.3. The T1, of course, is not 100, it's 75. Watch out for that. Okay? Your ratio, well, you know your ratio is 0.75. Oops, 0.75, not 0.75. Here we go. Okay, 0.7. There we go, to the n minus 1. Okay, so what do we do here? First things first. Divide by 75, divide by 75. So let's bring up our calculator here. So 13.3 divided by 75 is going to be 13.3 divided by 75 is going to be that ugly mess, 0.1773333. Oh my goodness, 0.177. Let's deal with it with that. 0.177. 0.177 is going to equal to 0.75 n to the minus 1. Now, do you remember how to do this? Well, let me refresh your memory. It's actually pretty easy to do. Let this be y1, let this be y2. The intersect is going to give you the exact value of n. Oh my goodness, that sounds like way too much fun. Okay, so let's bring up our calculator, put this 0.177333 repeater in for y1. So 0.17, what was it? 177, oh, I can't find it now. Oh, wait a second. Let's quit this. Oh, there it is. 0.1773333. Okay, 0.177333333. And you could just load it up if you want. I don't care. That's pretty accurate. Let's go to the next part. Do you remember the second part? Oh, the second one is over here. 0.75 to the n minus 1. Okay, 0.75 to the power of n, or just x, minus 1. There it is. Graph this, bada-bum, you're going to get something that looks like that. But you can see that they're intersecting right around here somewhere. Okay, so find that intersect. Very easy to do. Second calc, find me the intersect 5, mouse it over there, get it a little closer, bump, 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 enter, 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 and you'll find that this is actually at 7 bounces. So if you think about that now, you can go over here and say this term actually happens at T7. Now, if you don't believe me, well, just go out there and do this 7 times. Go, okay, times this by 0.75 times 75 times 75, or I should say 75 times 0.75 times 0.7 times 0.75. Oh my goodness, I'm getting all confused. Let's just do it anyways. Okay, so here we go. Second quit. Clear this out of here. Clear. Okay, now, so we said that we're going to take 75, that's your first bounce, times 0.75, there's your second bounce, right? Times 0.75, there's your third bounce, times 0.75, there's your fourth bounce, times 0.75, there's your fifth bounce, times 0.75, there's your sixth bounce, times 0.75, there's your seventh bounce, and it's 13.3, just as we predicted way back here, 13.3. So that works beautifully, right? So for the rest of this question, I'm going to make another podcast because this podcast is getting long. So this is a really nice way of reviewing how to find the term number when you're asked to find a height of how many bounces.